Thank you very much, and welcome everyone as well from our side to today's regional meeting. So Nico and I have about 45 minutes now to try and jump into some of the technical highlights of all of our projects. Unfortunately, we're making it difficult with every regional meeting because we keep adding new topics, keep adding content. And so we'll do our best to give you as much insight into the different activities going on in OpenX. But again, if you have any questions, just reach out to us and we'll be happy to help you out or jump into more depth.
Yes, perfect.
Okay, so as Klaus already introduced us, I guess very quickly again. So I'm Ben Engel, one of the two technology managers for the OpenX domain, together with my colleague, Nico.
So my name is Nico Dillmann. I'm the other global technology manager. And as Klaus already introduced us in the beginning, I'm more for the static stuff, and we will cover it a bit later in the slides.
Right. So where the layout for our workshop or our session today is just to give you a quick overview of what activities we have ongoing for which standard or soon to be standard, and then go through them one by one and show you some highlights of the current development work. Yeah, so if it's an ongoing project, maybe just share some of the developments going on in those projects, and of course, if it's just started or whatever, then we'll try and just give you the key information with respect to the status of that project and what's planned in the near to mid future. So sharing here on the screen at the moment, we have our seven and a half, let's call it, standards that make up the OpenX portfolio. At ASAM, this is also called the simulation domain, and the OpenX simply because we like putting open in front of all of our standards to indicate that they're open. And going through them very quickly, most of them should be familiar with most of you already. So we'll be quick here. Open scenario, of course, for the dynamic content. Yeah, this was one of the original standards in the portfolio, intending to allow a user to describe scenes. Yeah, so dynamic content and also reference static content, road networks into this for complete scenario descriptions. We have Nico. I'll just jump through mine and then let you jump. We'll just jump back through these. Then we have the Open Simulation Interface, of course, also called OSI. And this is intended this is one of the new additions to the ASAM portfolio. And this is a generic interface, a messaging format originally intended at least, to provide a generic interface between ground truth information, sensor models, and some AD functions or perception functions. We also have the OpenX ontology, which is intending to represent this whole domain that we're addressing with our OpenX standards. It's intending to formalize this domain through an ontology. So here talking about taking the taxonomy, so all the terms that are being used by all of these standards, coupling them closely through this ontology, defining the relationships amongst these individual terms, with the goal, of course, of really increasing not just the compatibility of the standards with each other, but also of making the industry as a whole, making it much easier for the industry as a whole to make sure that everyone's talking about the same thing. So provide a way of very clearly describing what terms are being used, and also an approach of mapping these terms back and forth across different standards. And then we have one more, which is in parentheses at the bottom. And we'll have some more information on that at the end of the session, so I'm not going to say anything on that. And then we have all of Nico's standards. So Nico, I'll pass over to you.
Now switch over to the static part. There we have OpenDrive. OpenDrive is an XML-based format. Now we will cover it a bit further in the slides now to describe the semantic parts of a road network. So it's just the semantics and how the road network is described in that format. Then we've got OpenCLG, which is about
is it me or is it Nico?
Binary format road surfaces that comes as okay.
Sorry, Nico, we just lost you for a second there.
Yeah, I've just got the info that my internet connection seems to be unstable. Let's see if we can get through it without any further ado. So yeah, and then both of them, OpenDrive and OpenCLG, have legacy standards, and OpenDrive 1.6 was released in March this year as the first ASAM OpenDrive version, and we will release OpenCLG 1.2 within November TC. So that is really close to come. And then we have OpenLabel, where we just finished the concept project, and we are currently in the process of writing the new proposal, but I don't want to spoil anything here because we've got a presentation trailing our presentation, diving way deeper into the details of the OpenLabel concept project. So we will keep that short. And then, of course, we have the OpenODD concept project. Here we are currently in a concept project phase where we are tackling the problem of describing a operational design domain in a machine-readable and comparable format. And here the project just started, and we are currently still in the beginning, but that is going to be very interesting. We are going to cover it later on a bit further. And with that, I'm done with my standards.
Okay, then we have one graphic that we wanted to share, and we're sharing this a lot wherever we have the chance to share it. And our aim is just to increase the visibility of this topic. So what we're sharing here is our interpretation, based obviously on our expertise and our discussions in the groups, on one way and one example workflow that this whole OpenX portfolio can or could work together in a workflow. Yeah, and what we're showing here is a so-called scenario-based or scenario-driven testing workflow. One obviously very industry relevant topic at the moment, and how the OpenX standards can be used in such a workflow. And what we're trying to do here really is show, if we look, for example, on the left-hand side, so I won't go into too much detail because this is a presentation for itself already, but on the left-hand side, we have multiple specification sub-steps, right? So we're looking at specifying some tests, right? We're looking at testing some function or some piece of hardware. We need to specify what exactly we're testing and how we're testing it and what our expectations are. We also need to describe in what scenario or what ODD we're testing this, right? So for this, we've also placed some of the ASAM standards that are required to do so. Once we have this specification, we need to run it. Yeah, so we need to run our scenarios, run our tests, and we can do that either, of course, in simulation environments, in some physical environments, or some combination thereof. And again, here we've put some of our standards here, looking at ASAM Open Simulation Interface, and another standard that's open source, with which we're very closely associated, the Open Materials standard from BMW. And basically trying to show with this whole graphic how the standards could work together. Yeah. So, and again, we'd be more than happy to dive into details to each of these individual steps in later sessions, and we'll also come back to this graphic at the end of today when we come back to talking what the newest activity is for the OpenX portfolio. And I think that moves us right on to some of the project highlights. And then we're back to you, Nico.
Yes, so we're going to start with OpenDrive. So OpenDrive is as I said before, a description format to describe the road networks. OpenDrive is all about the reference line, and everything is attached to that reference line. Of course, you can position different objects in a global coordinate system where the reference lives in. But so yeah, the whole purpose of OpenDrive is a description of road networks, and there it is important that it's the semantics of the road networks and not the graphics. So OpenDrive is usually used for drive simulation or traffic simulations.
Okay.
We have a bit problems here with the line.
Need a road network as well in sensor simulation because your virtual. Okay. Can you hear me?
Now we can hear again, but you have been away for some seconds.
Okay. So what I just said is that OpenDrive is used for simulators in the for drive simulation and traffic simulations, and of course as well for sensor simulations. What I will do is I will turn off my video. Maybe this is going to save some bandwidth. And then of course, OpenDrive is XML based, and there's a hierarchy model, data model behind that. And the basic elements we have within OpenDrive are roads, junctions, and controllers, while controllers are only referenced within OpenDrive and are used, for example, for traffic lights. So controllers are already covering and going into a dynamic part. We still need them to reference them in OpenDrive, because in OpenDrive you're going to describe the position where your traffic light is going to be on the road, or where that logic stop line for that traffic light in case of a red light is going to be. So yeah, and of course, all the features like traffic signs are attached to that reference line as well. And then in the lower image, we can see how individual defined roads are put together with a predecessor and a successor. So that logic can also be used for navigating that road network and knowing where I can go from a certain point. So in this case down here, from road ID 1, I could go either to road ID 3 or into that junction with the ID 2. Yeah, what is not covered in OpenDrive are all the acting and interacting entities, and that is going to be covered by more by OpenScenario. So I'm not going to talk about that. And what I want to show you, because what is very difficult in OpenDrive is the junction modeling, and that is what you can see here, because what you have to do is create every possible connection within a junction, and in that junction you will then have many roads going from whatever possible ways you could go in that junction. And for each of that possible connection, you have to create a road. And of course, those roads are going to be overlapping, as you can see here. But that will give us, or that will come with some problems, because, for example, here we have a gap in that junction area. So as OpenDrive doesn't know the concept of having ground, if there's no road defined, there you actually have a bottomless hole within that junction area. And that is something we tackled in the concept project, and we are going to implement in the next OpenDrive development project. Or for example, here we've got another hole because there we've got a too tight turn, and there in that case we only have the sidewalk, and the actual driving road is parted from that. So yeah, and there are a few more holes in that junction area we would need to cover, either by creating width in that in the individual overlapping roads. But this is just one of the problems with those overlapping roads. Imagine if you want to tilt or have a super elevation applied to that junction area, you would need to have each individual road adapted to each other to create that smooth surface over the whole area. And that is very, very complicated, and in many, many ways not feasible. So that is one of the improvements we tackled in the concept project, where we said, for once, it is going to be important to know what is the actual junction area. So we are going to provide methods to define that junction area, as you can see here with the green borders. So there you can say, okay, this area is going to be the junction area and my ground, and the lanes and the overlapping roads within that junction area are still important because you need to know them for routing, but not anymore for defining the road surface where you can actually drive on. And what, in addition to that junction border, we are also going to introduce a concept of a junction road. And that is pretty much a helping concept that lets you put in objects into that junction area. So now you can place traffic islands or signs or whatever in that junction area according to that junction road, while that junction road is, of course, then attached to the junction area. And now, as I said before, having that tilted junction surface is quite difficult. We took the concept from OpenCLG with a grid and applied that to that junction road. So now you're able to actually apply a slope or a tilt to a junction area using such a grid. That is the resolution of that grid is of course free to choose, but it is way rougher than a OpenCLG grid would be. Yeah. And with that, I can come directly to OpenCLG. And OpenCLG is a format to describe road surfaces in high detail, and is usually used for vehicle dynamic simulations and tire simulations, as well as driving simulation, where you need high fidelity definitions of the road surface. And what you can see in the left image is the reference line that is defined in an OpenCLG file, and attached to that reference line, the perpendicular grid that is bent and turned with the reference line. And each of those squares in that grid will contain a numeric value that is then interpreted by the simulation either as elevation value, as on the right side with that cobblestone street, or it could also be interpreted as friction values. So then you would have a map of what friction coefficients do I have at what point on the road. And what I said before is that the OpenCLG standard comes with a MATLAB API and a C API, and those APIs have different tasks and different methods they provide. So the C API and the MATLAB API are both going to provide evaluation methods, so you can check if you have a valid OpenCLG file, you can read the file. And of course, with the C API, that is way quicker than with the MATLAB API. But the MATLAB API comes with possibilities to modify your OpenCLG file. So you could add a ramp onto that OpenCLG file from a certain point, or you could actually also generate OpenCLG files from measurement data, and it will help you visualize the data so you know what you're doing. And the image you saw before on the right-hand side was created by MATLAB. And to just quickly visualize how an OpenCLG file looks like, here's the texture representation of an OpenCLG file. So you've got on the top the header information and the long section definition, so you know how high the resolution is and how many long sections you actually have. And then you have in the green box the heading at the certain row of the grid. So once you've got a turn or a bend in the reference line, that of course means having a different heading. And then in the orange, yellow, and blue long section, you have the values along with the heading defining that grid. And the reference or the coordinate system for the reference line here is pretty much drawn into the number grid. And you can see here both axes, the V and the U axis. And that coordinate system, what you see here, is the same coordinate system you would see in OpenDrive for placing objects. There it's called local coordinate system and is used to place objects, because of course you can place OpenCLG files within OpenDrive, for example, to patch a very detailed pothole onto a road. And with that, I can hand over to Ben for OpenScenario.
Great, thanks, Nico. So before I jump into the different projects here, I see quite a few different new names. So maybe I'll just take a step back quickly and provide some background to OpenScenario. So OpenScenario, the first release of the ASAM version took place this year in March, where we released the version 1.0 of OpenScenario. And this, again, OpenScenario is an XML-based format that allows for scenario descriptions. So over time, action and event-based situations that are relevant to traffic participants, including also environmental conditions and road network and any other aspects that might be relevant for whatever it is I'm describing. And this was a project that went on for roughly 1 year. And we very quickly saw the need that on the one hand, the standard is nowhere near yet perfect, particularly because we at ASAM realized that because the industry is moving so rapidly, rather than having very long development pipelines that take multiple years, as is the case in some other industries or in other other domains, we really need very fast turnover with respect to the releases of ASAM OpenX versions, which is why a lot of our projects have such short lifetimes, so around 1 year. And this was the same for OpenScenario 1.0. And obviously, we're aware of the fact that in 1 year, you can only get so much done. And our aim is really to iteratively keep improving on what we have, rather than waiting until we have the perfect solution. So with that in mind, of course, we very instantly after the release in March of this year, we initiated the follow-up project, so-called 1.x, which is the follow-up project to the 1.0 version. We'll be releasing a 1.1, so a minor version, an iterative improvement on the previous version in March of next year, and continue on from there. And what we're aiming to do here is really significantly extend what we released in March of this year. So really clarify the content that's there in, for example, the user guide, really to really help people understand how this very new standard should be used, and also how it should be used in combination, for example, with other ASAM standards, and how it should be implemented. And particularly with the implementation side, there's a lot of gaps still in the 1.0 version that, whilst they were improved over the version before that, are nowhere near perfect. So I'm going to keep saying that. So one of the biggest topics that the group that's currently ongoing is addressing is looking at runtime. So when a scenario is running, and whether it be in a simulation or somewhere else, how is the interaction between the individual entities in this scenario taking place? And with entities, we mean such things like traffic participants, pedestrians, and how do these interact with each other? Because of course, in any realistic situation, we have multiple events taking place in parallel, and this very quickly gets complicated if it's not clearly defined. So looking here at really improving the detail on how these entities, the actions that they take, and what is controlling them, how they interact with each other. And in OpenScenario, a controller is basically a way of, in a simplified fashion, it's the behavior that it controls the behavior of an entity. So if you look at a vehicle, it's being controlled by a controller which prescribes how that vehicle should be behaving. And how do these interact with each other? How do different entities in the traffic situation interact with each other? So that's one part that's being significantly clarified. One other big topic that's been very much requested by a lot of users that are starting to implement OpenScenario 1 is some extension to the parameters side of things. So looking at providing a basic expression syntax for parameters that allow me, of course, to perform some basic parameter manipulation. So allowing me to much more easily generate, let's say, stochastic scenarios based on parameter ranges and things like this. And we're also providing some default distributions so that I can define a parameter, and rather than assigning it a discrete value, I can assign it a distribution of some sort. And again, here looking at generating multiple scenarios, thousands of scenarios based on these different parameter distributions or ranges. And this obviously makes that much more simple without having to resort to external tools. And we'll be aiming to release that again in March of next year. And based on continuing feedback, we're already starting to collect a list of new features that will come in the next version after that. So if you're starting to use OpenScenario 1.0 and you already have some points that you think need improving, get in touch and we'll make sure to make a note of it and integrate it into the development to make sure that it doesn't get, that it gets addressed, and if it's not already being done so in a future version of OpenScenario. So really looking here at continuing actively the development on this 1.0 branch of OpenScenario. In parallel, of course, to OpenScenario 1.0, there was a requirement in the industry for significantly more feature-heavy way of describing scenarios. So in parallel to the 1.0 development project of last year, we started the so-called OpenScenario 2.0 concept project, which aimed at looking at the current or future or upcoming requirements in the industry for scenario descriptions, and looking at, well, what do we need on top of what's being developed in the 1.0 version? What do we need to really make this usable for level 4, level 5 driving development, or AD function development for level 5? And one of the most important things that cropped up here is really the requirement for a domain-specific language, making it easier for us as users to describe scenarios. So that's the big goal of the Open Scenario 2.0 project. Yeah, we started last year again with the concept project, released a concept paper in March of this year, and continued on directly now with the development project. And this development project is intending to release this 2.0 version of Open Scenario in the summer of next year, so around July, August of next year. And this will include, on the one hand, the domain-specific language that allows me, on top of my very concrete scenario descriptions using Open Scenario 1.0, that allows me to describe scenarios using this domain-specific language. And here looking at all sorts of description approaches. Yeah, so from the very concrete all the way to functional or logical scenarios, as they were known, for example, in the Pegasus world. And so really looking at allowing for different users or different requirements towards scenarios to be fulfilled. So a regulatory body does not need very concrete scenario descriptions. Looking here at enabling this through this domain-specific language. And providing, of course, clear guidelines on how to transition between different levels of scenario abstraction. So a very abstract scenario that's very easy for a human to read needs to be obviously converted into something that a machine can understand. So with clear values for all the different parameters that are being used and things like this. And to do so, or how do I do so in an implementation? And how, from a standardization perspective, do we ensure that this is always done the same way? So that's what this standard will provide some documentation on as well. Also looking at defining a domain model. And so this is actually in parallel to the previously mentioned OpenX ontology project. It's also looking at domain modeling. And here, looking at a more restricted scope, namely the sort of the domain that is addressed by the domain-specific language, yeah, which is more specifically the closed-loop system testing for AD, on-road driving. And obviously, this will make it easier to define the syntax and semantics that the language uses based on the domain terms that are defined in this model. More on that in a second. And because we know that there's very many different use cases for for using scenarios in the industry at the moment, whether it's testing oriented, whether it's modeling oriented, or whatever else, we're going to provide a set of clear guidelines that show how Open Scenario 2 as a description format for scenarios can be used in these different usages, to provide some guidance on people to people really to help them understand how this language or this description language fits into the big picture. And because, of course, it's confusing that we're working on two different versions at the same time, again, here to clarify, Open Scenario 2.0 is going to be compatible with the 1.0 versions. They're going to continue to be developed in parallel. The difference here being, of course, that Open Scenario 1.0 allows for very concrete scenario descriptions in an XML-based format. And 2.0 builds a layer on top of this by providing a more concrete domain model and a domain-specific language with significantly increased functionality. But the expectation towards both versions is that the runtime behavior of scenarios in 1.x will be the same as scenarios in 2.0, provided that the functionality is supported by both. Yeah, so 2.0 is intended to be a superset of features in comparison to the 1.0 development pipeline. And I think I actually have a couple of slides on the next pages that go into some detail, and I'll fly through them because I've just seen that we're already starting to run out of time. So one of the big aspects that we realized in Open Scenario 1.0 is that it's for such a new standard, such a large scope, it becomes very difficult to implement it in an easy fashion. And we're seeing it in the tooling that is starting to implement 1.0. So if we look at some of the open source tooling, if we look at Kala, for example, or AS Mini, which are visualization or simulation tools respectively, they have started to implement the standard, but obviously it's a very big standard and it's difficult to do at once. So they haven't got, they support parts of the standard, but not all of it. And it's not always entirely clear what is actually supported and what isn't, and what parts or what features can I use in one tool in comparison to in another tool. So Open Scenario 2.0 is going to make this more specific or explicit by defining so-called feature subsets that are a clearly delineated set of features in the language that I, as an implementer or tool user or scenario designer, can clearly indicate are required in my scenario. So it makes it clear what features are required for the scenario, or I, as a tool implementer, can clearly indicate which feature sets do we support as a tool vendor. And this makes it easier, of course, to interchange different scenarios between one another and exchange scenarios, to exchange scenario descriptions effectively. And that brings us to, so that there's a lot of different feature subsets that are being proposed at the moment. And the idea at the moment for 2.0 is that we'll just release a proposal for how we want to modularize the language, rather than already implementing such a modularization. Because this is something that is dependent, of course, on the other parts of the development activity and is difficult to do in parallel because we don't actually know what's going to be the outcome of some of these groups yet, specifically. So that moves us on to the next highlight of the OpenScenario 2.0 project. And this is something that I want to harp on a little bit about, which is that scenario descriptions, and this is, let me take a step back. In OpenScenario 2, we've already said that one of the things that we want to release is a set of guidelines on how to use OpenScenario. Because we see that whilst the standard might prescribe how certain language elements or certain standard elements can and should be used, this does not always mean that the understanding of this description is the same. And so what one person might understand with how to describe a scenario, someone else might do it completely differently. And this is why we're proposing to start a so-called implementer forum, with the goal here of supporting implementers in developing a shared understanding of how to use the OpenScenario 2 language to describe scenarios. To make sure that when the language is released, that we already have at least a basic shared understanding of how this language should be used to describe scenarios amongst the industry, rather than having this happen in a serial fashion where we release the standard and then hope that the implementers come together to some shared understanding. Simply because scenario descriptions are very dependent, or much more dependent on interpretation than maybe other forms of standards that describe clear APIs, for example. Yeah, and this is very closely linked actually to the set of workflows that we're going to provide. Yeah, and I've just got a couple of the workflows mentioned down there that just show what sort of different levels we're looking at. Yeah, so the regulation perspective, the simulation perspective, the testing perspective, automation perspective, all different perspectives that we're looking at really to make sure that the different users of scenario descriptions are able to, well, that we fulfill the requirements of these different users. And moving on. So then we have one more aspect that I just wanted to touch on, which is the domain modeling aspect of OpenScenario 2.0. And again, OpenScenario 2 is looking at providing a structured domain model, but it doesn't want to start, as was mentioned in the previous presentation, it doesn't want to reinvent the wheel. So it's actually looking at existing domain modeling work in the industry. So looking at, for example, our own OpenScenario 1.0 standard, which has a rough, or has an initial domain model. Also looking at other standardization activities, yeah. So whether it's ISO or SAE, they have lots of work on defining parts of the domain or different domains, making sure that this information is integrated into the domain modeling work in OpenScenario 2.0. Yeah, and then the expectation as an output of all of this, yeah, is just basically a harmonized domain model that attempts to align all of these different, all of this different content into a unified domain model for OpenScenario 2.0. with some clear guidelines in how this can or should be extended should the scope not be sufficient for our users' purposes. Okay. And that's sort of a quick overview of OpenScenario 1 and 2. Again, we're actually planning a bit more of a detailed news release for OpenScenario 2 in the next weeks, so stay tuned for that. We have, as a next standard, the Open Simulation Interface. And this, again, because it's new, is a generic messaging format that currently is encoded in Google Protobuf that allows that provides an interface between ground truth information in my simulation, to my sensor model, yeah, to provide a generic interface there, and also between my sensor model and whatever AD function I have at the end that takes the output of my sensors. And the motivation behind this was really just, or it initially started actually as an initiative between BMW and the Technical University of Munich, simply because the problem in the industry was that tier 1 suppliers were providing sensor models that were tested in their simulation frameworks, providing these sensor models to OEMs, who then obviously had to integrate these sensor models into their own simulation frameworks, and realizing, of course, that these models are very dependent on specific simulation frameworks. So OSI was born effectively to abstract away the details of this implementation of the simulation framework to allow for this interchangeability of different sensor models into different simulation environments without having to worry about exactly what the implementation details are. And it's a completely open source standard that's actually on GitHub. So if you're interested in looking at the development activity there, feel free to have a look at it. Feel free to join in. And the development itself is actually open source, and that's going to continue in the future. It's ASAM's first open source initiative, completely open source, right? So because the other OpenX standards are available openly, free of charge, but the development activity is restricted to ASAM members, and this is not the case for OSI. And so we're keeping over. This is sort of an experiment as well at ASAM to see what implications this has from a standardization perspective. So I did actually have a graphic on the motivation. Again, here the reasoning for how OSI was born. Yeah. So we'll just jump over that. Thank you. And just a very quick diagram that demonstrates where the open simulation interface, where OSI plays a role in a simulation environment. So as we see here, we have some environment simulation, which is of course presenting to my entities, my models, some version of the ground truth, so reality effectively. OSI takes this ground truth and presents it in a sensor-specific view to the sensor models. And this is dependent on, of course, what each sensor might see. So a radar sensor will, of course, see different information than some LiDAR or some camera sensor. And of course, OSI then, at the other end of it, provides an output. So it takes the output of the sensor model, converts it into some OSI generic format, and passes that on to my AD function or some sensor fusion function. But more on that, we did actually hold a crash course on the open simulation interface a month and a bit ago, 2 months ago. That's available on our website. So if you're interested in the technical details of OSI, please feel free to have a look there as well. We started the first project for OSI in June of this year. And what's happened is that the scope is significantly grown. So what was previously called the open simulation interface is probably tricky wording, right? Because it was actually just an open sensor interface. And the first ASAM project is intending to really make it live up to its name as an open simulation interface. So we've significantly increased the scope of OSI, looking at not just providing support for more detailed sensor models, which is of course a very industry relevant topic, right? We're looking at providing support for physics-based sensor models, stochastic-based sensor models, right? So much higher fidelity sensor models, and these require more information to be supported by OSI. But also looking at providing more generic interfaces for other parts of the simulation. So allowing interfaces between individual traffic participants, allowing for OSI to act as an interface to some driving simulators that I can connect to my simulation, or acting as an interface between different agent models. And this, of course, makes these models more plug and play, but it also allows me to interface much more easily with these individual actors. So I could, for example, use now easily OpenScenario, which sends obviously action-driven commands to my traffic participants, to my entities in my scenario. I could send this information via OSI messages. So that's one way that we're looking at bringing these standards closer together. And of course, the more we extend this standard, the more performance becomes a topic. So we're also looking at improving the performance of OSI. Yes, especially if we look at things like real-time simulation or faster than real-time simulation, we need to make sure that OSI is able to support these use cases, to support the amount of data that's being sent for real-time. And to do that, we're looking at different approaches. These include different encodings, for example, Google Flat Buffer, which is a binary encoding, reducing the amount of information that gets sent so we don't send unnecessary information and things like this. And finally, of course, we're looking at harmonizing, again, all of our standards more closely. So we're looking at ID management. And this, whilst it's being driven from OSI, is something that's involved with all of our other activities. To make sure that when I talk about one entity, one ID in standard X, that I can map it to another standard and still actually be talking about the same thing. Right? So what might have an ID of 1 in OpenDrive might not necessarily be the same object in OpenScenario, and we need to have a way of clearly mapping these IDs back and forth, and that's what we're looking at in OSI here. And lots more, right? So again, feel free to look at the proposal or the GitHub to gain a better feeling for it. Okay, I'm going to have to speed up because I think we have 5 minutes left. So we've gone over time a bit. So OpenX ontology, domain representation. Yeah. Looking again at formalizing the domain, harmonizing the terms being used across all of the ASAM OpenX standards, so Open Scenario, Open Label, OpenDrive, OSI, amongst others, and mapping these to another and harmonizing them in an ontology. Looking at releasing a first example of such an ontology towards the end of this year or the beginning or January of next year. And this example will help demonstrate through a very, very small domain, so looking at one driving context at the moment, how the ontology can or should interact with other standards or with other tools. And of course, this will help people understand how this fits into the big picture in order for us to continue developing the ontology, aiming to release the full version for the full domain towards the middle of next year. And this minimal working product will demonstrate, for example, how an ontology can be used to support labeling activities, or how an ontology can be used to support scenario generation or scenario checking, and things like this. And again, we'll be releasing that to the public as soon as it's ready. So again, here aiming or on track for end of this year, beginning of next. And I'm done, Nico. Sorry.
Okay, great. No worries. So as for Open Label, I'm not going to spend too much time on that because we've got a trailing presentation after our presentation by Nico Groce, and he will dive into that topic in more detail. The thing is that Open Label there was a concept project that is finished now where we looked into how can we standardize the annotation format for object labels and scenario data labels. And the focus here was on how to label, so describing the format and the methods. And here you can see a simple example on a 2D bounding box labeling a person and a traffic sign. And of course, there are many different ways on how to describe that box. And we looked into standardizing that and putting that into a common understandable JSON format. And of course, we had 4 work packages. We had the annotation format. Then we looked into labeling methods. We also had a close interaction with the OpenX ontology, what Ben just mentioned, regarding the taxonomy of the labels. And of course, we had that one work package regarding scenario labels, where we looked into, okay, how could we categorize and label scenarios for a use in a database to find the scenarios I'm interested in. And the concept paper is going to be released in the end of November this year. And we are aiming to start the new development project in December this year. So we are currently writing the project proposal, and the proposal workshop is going to be mid of November. Have a look on our homepage if you're interested and register for that. So yeah, and then we will start in the beginning online working group project on the development of Open Label 1.0. Yeah, here are just a few examples I would jump over right now because there's going to be more in the end after our presentation, and jump directly into OpenODD. So the concept just started, the concept project. It will run until next year in August. And we are looking as an outcome of the project on a concept paper that will have a concept for the attributes needed in a ODD format. Also having KPIs to define, or methods to define KPIs to determine if a scenario is within or outside of an ODD, and also gathering input and concepts on how could we use ODDs for or that ODD format for safety analysis and uncertainty and rare risk, so for hazard analysis as well. And what we will also create within that project is a basic user guide on how the group and all the experts within the group sees how you could apply the OpenODD format to your development cycle, and how it could actually help you limit your necessary tests. Because when you look at a simple urban scenario, what you can see here, that is completely different, but could be labeled the same as the one on the right side. So you would expect different things from those two urban scenarios, so they're not the same. And that is something we need to reflect in that operational design domain description. And we need to be able to represent that. So I've added here the SAE definition of an ODD, where we say, okay, we need to be able to represent the operating conditions under which the autonomous vehicle is able to operate safely. And we, of course, what we need to enable is that you can use that ODD to well, calculate or perform operations on that ODD, so you know if you're inside or outside your ODD, and by how much, or on by what amount of time. Yes. So, and that of course includes all the characteristics of traffic and environment, geographical topologic information, time of day, weather, so the whole, everything pretty much. So I have a simple, very simple Tjunction example here. We're going to jump through that rather quickly. And the three ODD buckets, so to say, we have that are taken from the past 1883 that was published in Q3 this year, is the scenery, the environment, and of course the dynamic elements. So here the scenery would be a divided single lane T-junction. And if we would describe that in OpenDrive, I guess we would be roughly around 500 to 1,000 lines of XML code. And here it's rather simple, having two labels. We have 4 traffic participants, so 4 vehicles. Describing the actions of that would be probably a bit more than having just that passenger label in OpenScenario. And then, of course, we have maneuver descriptions, where in an ODD I need to just define, are those maneuvers, or what I want to do, is that something where I can operate safely in? And when do I need to, stop or change my behavior to stay in a safe mode of behavior? So there's a lot of going on regarding the definition of ODDs throughout many standardization organizations, and all of them are tackling the problem of what is going to, well, what do we need to put into an ODD? And that's where we at ASAM found that, for once, okay, it is very important to know what we need to put into an ODD, but it is very important also to have a machine readable and comparable representation of that ODD. And that's what we are tackling here. So we are not focusing on the what to put into. So we are going to get that from, for example, the past 1883, the ISO working group, or the SAE ORAD. And we are rather focusing, okay, how can we represent that so you can actually use it within your tool chain? And with that, that was really quick going through OpenODD. The last topic, but not the least, is OpenTest.
Yeah. So again, quick disclaimer, OpenTest is still sort of a placeholder for us. We don't want to have this name slip through. So we're still, that's still open. So we've come back to this diagram quickly because we just wanted to show where we see a gap, which is, I think, Nico, if you go to the next slide, highlighted. And specifically in the discussions in the ODD project or in OpenScenario, a lot of discussions have been with respect to testing. And how do I use scenarios and ODDs together with some test specification? And where are the boundaries between these, if any? What goes into what? What is a test specification? What is a scenario test specification? And these discussions have been very varied. So there's a lot of different opinions which have shown us that there's a lot of different ways this could be interpreted in the industry. And to help or to help clarify this for the industry as a whole, we want to initiate an activity, a study group, that just looks at these different understandings, these different workflows, these different usages of these terms, and provides some clarity. What exactly does that mean? Where is there an overlap? What implications do these different workflows have on maybe the usage of the ASAM standards, but also going beyond that, what other implications might they have? And also looking at the classical world of testing, which is now obviously coming more into the role here. How does this then play or interplay with the current OpenX standards? So this is really just a study group, which is why I'm saying OpenTest is still TBD. We've actually called it the test specification study group, and this is going to look at, like I've already mentioned, scenario-based testing, and looking at defining the borders there, but also looking at these classical testing methodologies to understand, what does that mean in this concept, but also, do we need to do anything further from a standardization perspective to support this? So this is a very quick study group. It's intended actually to start in November. The first workshop is open for registration and open for everyone, which is the 17th, I believe, of November. That's on the ASAM website. We can share that. Feel free to sign up there. There's also a proposal, a first draft available on the ASAM repositories for review. And the idea here is really, starting in November, is for it to run until the end of Q1 next year and provide some clarity to ASAM and the industry. What does the standardization industry need to do to continue supporting this? Do we need to develop a new standard to provide support for test specifications? Do we adapt existing standards, or how do we continue pursuing this to support the industry in scenario-driven testing and testing in general? So if you're interested in that, we'd appreciate your input. Feel free to provide some feedback on the proposal. Yes, we're looking for that. And in the workshop on the 17th, we'll review that content and start setting up a quick roadmap for the next months. And I think that concludes our presentation. Oh, wait. Okay, so maybe we'll just jump through this. I think this is something that we can fly through, right? So it's structural topics. Maybe if you're interested in this, feel free to have a look at the slides offline. We obviously have a lot of emphasis on harmonization across the OpenX projects. We're doing a lot to ensure that this is as easy as possible. So we have the workflows that are shared across projects to make it easy to jump back and forth. We have the ASAM coordination group, which is a group that started towards the end of last year with the intent. It has representatives from all of the ASAM OpenX projects, as well as external consultants and participants from other organizations like ISO. We also have participants from research projects in Germany, just with the idea of providing some platform to allow for alignment inside and outside of ASAM. And to, if further discussion is needed on a technical level, basically to connect the right people. And really looking at making sure that the OpenX projects are aligned with each other, with external activities, that we don't repeat work, that we're not competing with existing activities, and that we enable and support whatever else is going on worldwide as well. And I think then we can jump over the next couple of slides, Nico. I think they present some, yeah. Exactly. So to finish us off, when I just mentioned collaboration and alignment with external and internal organizations. And this is something that we wanted to finish off on today. And we feel as ASAM, particularly in the industry that we're all active in at the moment with the OpenX activities, so looking at AD development at higher levels of autonomy, standardization is really a key factor to enabling collaboration and sharing of information in the industry. But particularly because we provide a neutral, non-competitive platform to do so. But the problem with this, of course, is that it only happens if standards are adopted. And standards are only adopted if they're not confusing or conflicting, which really serves to emphasize the need for very close collaboration in the standardization industry. So before the AD industry can collaborate, we need the standardization organizations to collaborate with one another to ensure that the roadmap, that the landscape is very clear, not conflicting or confusing, to really support adoption of these different standards. And where there might be overlap, to collaborate to ensure that this overlap is aligned, right? To make sure that we're not conflicting. And we strongly feel that more collaboration is needed now. Yeah, so we're already in close discussions, for example, with other standardization bodies like SAE, like ISO or BSI, and we really want to emphasize the necessity for doing this. So if you or contacts of yours are involved in other activities and you think some alignment or these activities would benefit from discussions that are alignment discussions with us at ASAM or just of the platform that we offer for alignment, then please reach out to us and help us in doing so, because we think this is one of the most important steps to reaching level 4 or 5 autonomy. And so we'll sort of leave you with a question, which is effectively, beyond what we've just mentioned, what else can we really do to assist in the adoption of these standards to really drive collaboration in the AD industry. And that's it from us. Thank you everyone for your time, and sorry for going over time.
Thanks everyone for your attention.